This tutorial will cover cloth simulation in Unity. The first thing I'm going to do is create an object to use for my cloth, and I'm going to create a plane. And the plane in Unity is not a very high poly plane, so if you wanted to create a high poly plane in Maya or Max and import it, you could do that as well. But I'm just going to use the default Unity plane, and you can bring in whatever texture you want to use. For this demo, I'm going to make a flag, so this will be my flag texture, and I'm going to scale it so that it looks a bit the size and shape of a flag. And I'm also going to rotate it so that it's facing my camera. There's my camera there. And so I'll do -90. And planes in Unity by default do not render the back side of the object. And if you wanted to have your flag be double-sided, you can find double-sided material shaders online to download, or you can also mess around with some of the built-in shaders in Unity to see if one of them will work for what you're trying to do. Some of the particle textures are double-sided, but they have unusual results when you can see things behind the object. You can also adjust the alpha if the alpha is part of the problem that you're dealing with. And I think the multiply might be the best one here. Or multiply double, that one looks all right. So that's the one that I'm going to go ahead and use for this demo. And I'm going to also have a flag post. So for that, I'm going to use a cylinder and scale that up to be my flag post. And now on the flag object, we're going to first remove the mesh collider. We don't need a collider for the cloth object. And add component. And cloth is the component we want to add. And the first thing that we can do when we add the cloth component is we can add constraints, which determines which vertices on the plane cannot move. And on a flag, the parts that cannot move are the parts that are attached to the flag post. So that would probably be the top two and bottom two vertexes. And to add constraints to it, check this box for max distance. And the first time you do this, you can set a value for your max distance. And that will actually determine what the upper bound is on this spectrum here. And this spectrum basically just lets you compare different values when you're looking across. So I actually want these two vertices to be completely constrained. So this max distance means this is how far these vertices can move from their start position. So I'm going to set that to 0, and then the ones in the middle, I'm going to set their max distance to 1. So I want them to be slightly constrained, but not completely constrained. And that'll just make it so they don't move around as much. You might also even take this second row here and give them a max distance of 1 as well, or maybe 2, so they can move just a little bit farther. So at each step, the vertices can move a little bit farther. The ones out here we want to leave completely unconstrained so that they will just behave as if they are cloth effects. They'll just flow smoothly with the physics. Once you're done editing the constraints, you can turn this off. And the next things we can change are stretching stiffness and bending stiffness. So let's first look and see what we have. So there's what our flag looks like right now. And first thing I want to do actually is move my camera farther back or shrink my flag down. I'm actually going to shrink my flag down. So I'll select the plane and the cylinder. Oops. And if you switch this to, oops. Switch this to center, then you can scale them both down at the same time. And for some reason the cloth is not scaling down. That's what this white border is here. So let's undo that. Alright, so I'll actually just move my camera back. That'll have the same effect for this demo. Move the camera back like so, and let's test again and see what that looks like. Alright, so bending and stretching stiffness. Stretching stiffness is how far apart the individual vertices can stretch away from each other, and bending is how much they can bend, so how much they can rotate around each other. So let's try 0.5 for each of these. And let's just see how that looks. So now you can see we have a bit of a different behavior there. And we're getting a little bit of strange crinkling here on the edge. So I think I'm going to go back into edit constraints. Oh, and it did not accept the constraint for these, so that could be part of the problem. All right, so let's actually, let's make the middle ones in here have a max distance, and I'm taking the second one on each end as well. So I'm actually going to give these a max distance of 5. And so just the top and bottom ones will be fully constrained. And then this row here, I'm going to unconstrain these. So to unconstrain them, just uncheck the box for max distance. And I'm just going to take the bottom one and give it a max distance of 6, and the top one as well. And you can also adjust the damping, so this slows down anything that's being affected. And you can also add external acceleration, which would be like if the wind was blowing. So we could add some external forces to, I'm going to add to the X and the Y, and we'll see how that looks. So we're getting a little bit more natural of a flow there. I'm not sure if I really like the material that's being used here, so I'm going to go ahead and change this to let's try vertex lit. Okay, so the vertex lit one looks better. It doesn't have that transparency through it. So now one thing you might notice is that the flag is actually able to pass through this post somewhat. And it might be a little bit hard to see, but if we moved this over so it's closer to the pole, I think you would see that happening. Yeah, so now you can see that the flag is actually able to pass through the pole. So if you wanted to prevent that from happening, you can add colliders that the cloth will recognize. By default, the cloth does not react to colliders, but you can add capsule colliders and sphere colliders. You cannot add box colliders, but depending on what you're trying to do, you might be able to find a way to use a capsule collider or a sphere collider to achieve that effect. So if you change the size here to 1, it allows you to drag a collider in, and this will now be recognized by the cloth. So the cloth will attempt to not pass through the capsule collider of this flag post. And you can see it didn't work very well up here, but it did work down here where the bottom swings against. And so it's not a perfect system. It needs to have a little bit of space to work with. So we can kind of pull this away a little bit so that it has a little bit more space to detect the collision. And again, you can see it working down here, but it's not working very well at the top. And it could also have to do with the constraints on that part of the cloth. Also, the collision mass scale can impact whether it's able to detect collisions as well. Okay, so that's looking a little bit better. And one last thing that we might want to add to this is we have a little bit of flow to it from the default external forces that we added, but we can also add an animation. We can animate how these forces are being applied. So I'm going to create a new animation called flag, and I will attach it to this flag object. And now in the animation window, we can add property, and we can, since we have a cloth component on this object, we can actually animate the properties of the cloth. So I'm going to animate the external acceleration. That's this one here. And so what I'm going to do is have a couple of different keyframes. So I've already set it to 2 normally. So what I'm going to do is actually, on my first keyframe, I'm going to set the Y higher so it'll actually drop a bit faster. And I'm going to make it negative actually. So -10 for the Y. And you can see already that animates to 2. But I'm going to add in the middle here, I'm going to add 5 and -2 for the X. So now all 3 values animate. And I'm going to have a little bit of buffer keyframes out here where I have the values of all of them set to 0. That will just allow it to fall with gravity and not be impacted by any external forces. So this animation is going to loop, and so every time it loops through, I want it to have basically a period where there's wind happening and then a period of calm between gusts of wind. And then make sure that you check the box for loop time so that that animation will loop. And then let's test it out. And so now we're having a bit more interesting behavior from the wind, but we can also see that having all those extra external forces are also making it difficult to detect the collision with the flag post. The forces are a little bit too strong. So let's go in and edit those. First of all, I'm going to also adjust my bending and stretching stiffness. Let's try smaller numbers for these. And I'm also going to add a little bit of damping. And I'm going to increase the collision mass scale. So hopefully we can have a bit better collision with the flag post. So the damping is now making it so our external forces are not applying very much force to it. So we can increase those in our animation window. So I'm going to set my starting external acceleration. Let's try -20 for the Y. And so now I also want to adjust the other keyframes as well. So this one here, let's bump these up. Let's try 20. And 12 for the Z. And let's see how that goes. So we're still not getting very good behavior with the edge of the flag over here. So I'm going to go back in to edit my constraints, and I'm actually going to add more stronger constraint along this edge here so that these won't pass through this flag post so much. So let's constrain these to 1, and I'm going to set the top one to 4 and the bottom one to 4. That's in this second row here. I still have 1 and 1 for the far corner, or 0, sorry. 0 and 0 for the far corners. And I think I'm going to turn down the damping a bit, so try 0.05 for that. And I think in my animation, I want one really big gust to happen at some point. So let's put that over here. And let's say that will be, let's try 20 for X and -20 for Z. Let's see how that looks. So that looks pretty good. We get some interesting blowing behavior from it. I do think I want to constrain this edge just a little bit more. It still has an awful lot of movement between those vertices. So let's select all of these and let's try 0.4. And I'm going to select this whole row here and let's constrain these to, let's try 2. And I'm going to, I think, increase my bending stiffness a bit so that they don't come to such sharp corners between the vertices. So now we're actually getting some sort of natural looking behavior for this flag. And this can be used for a lot of different things, not just for a plane. You can use this cloth simulation for bits of clothing that would be attached to a character, like a cloak or a scarf. You can also use it on other things like a tablecloth or a bed sheet, or a variety of different things that you might see in a game that need to have cloth-like behavior. It also can be used to create interesting effects with transparency, like with spider webs. So you could use this to have sort of dangling spider webs, or anything that would need transparency in it you can use, and it'll still sort of behave like cloth. You'll just be able to see through parts of it. So you can get some really interesting effects with that. So I hope you found this demo to be useful to see how to work with the cloth physics in Unity.